find the minimum point of the average cost function. Now this is the function that they gave us. AC, which is the average cost, is equals to 25q raised to the power of minus 1 plus 0.4q squared. Now look at the question. Find the minimum point. Minimum point. To find the minimum point of this function, you have to take the derivative of AC. After taking the derivative, you set the derivative equals to 0 and you solve for q. Now, if you want to differentiate this function, I'm going to be differentiating with respect to q because it is q that I have as my variable here. So I'm going to be having the AC all over the q is equals to, now don't forget, in the power rule we have the power, we multiply the coefficient. So I'm going to be having minus 1 multiplied by the coefficient is 25. So I'm going to be having 25 q, and the power will reduce by 1. So I'm going to be having minus 1, which is this minus 1, minus 1 plus this power. We also multiply this 0.4, which is the coefficient. So I'm going to be having 2 multiplied by 0.4 q raised to the power of 2 minus 1. Now the AC all over the q is equals to 1 minus 1 multiplied by 25. So I'm going to be having minus 25 q minus 1, that is minus 2, plus 2 multiplied by 0.4, that is 0.8 q raised to the power of 2 minus 1, that is 1. So q raised to the power 1 is q, so 0.8 q. Now after differentiating the function, we are going to set this function to 0. That is, I'm going to be setting the AC over the q, which is equals to this, to 0. So I'm going to be having minus 25 q raised to the power of minus 2 plus 0.8 q is equals to 0. Now after setting these equations to 0, I'm going to be solving for q. For example, if you look at this from the law of indices, if I have x raised to the power of minus 2, x raised to the power of minus 2 is also the same thing as 1 over x raised to the power of 2. If I have x raised to the power of minus 1, it's also the same thing as 1 over x. So if I have 25q raised to the power of minus 2, it's also the same as 25 multiplied by 1 over q raised to the power of 2. So therefore, applying the same law in this place, so I'm going to be having minus 25 into bracket 1 over q raised to the power of 2. So I have this here plus 0.8q equals to 0. Now if you look at this very well, minus 25 can multiply this one in the bracket. So I can have something as minus 25 all over q squared plus 0.8q all over 1 is equals to 0. Now I can take the LCM at this point. Q squared divided by q squared, that is 1. 1 multiplied by minus 25. So I'm going to be having minus 25 plus q squared divided by 1, that is q squared. Q squared multiplied by 0.8q, that is 0.8 raised to the power of q raised to the power of 3 equals to 0. Now I can set that 0 divided by 1, which is also the same sign as 0. So if I cross multiply, this q will multiply this 0, and I will have minus 25 plus 0.8q here. So I'm going to q raised to the power of 3 multiplied by 0 is equals to minus 25 plus 0.8 q raised to the power of 3. So q squared multiplied by 0, that is 0. So I'm going to be having minus 25 plus 0.8 q raised to the power of 3 is equals to 0. So if this minus 25, if I move it to the other side of the equation, I'm going to be having 0.8 q raised to the power of 3 is equals to 25. Now q raised to the power of 3 is equals to 25 divided by 0.8 of 3. Q raised to the power of 3 is equals to 31.25. So q is equals to 3 square root of 31.25. Q is equals to 3.1499. we have the AC function as this. We have taken the first derivative and we have gotten the value of q. Now the next thing is to take the second derivative of the function AC equals to 25q raised to the power of minus 1 plus 0.4q raised to the power of 2. Don't forget, at minimum point, the AC squared, the second derivative of AC over the q squared must be greater than 0. Now, at minimum point, when we take the second derivative of the function that we are given, the second derivative must be greater than 0. If the second derivative is less than 0, that means that this function is at its maximum point. And if it is equals to 0, that is the point of inflection. Now, let us take the second derivative of this function. Don't forget that the first derivative is AC. AC is equals to minus 25 q raised to the power of minus 2 plus 0.8q. Now, we want to take the second derivative of this function, and we have AC is equals to minus 2 multiplied by minus 25, that is 50q raised to the power of minus 3 plus 1 multiplied by 0.8. So I will have 0.8 q raised to the power of 1 minus 1. That is 1 minus 1 is equals to 0. Q raised to the power of 0 is 1. So there is no need of writing this. So the second derivative now is AC is equals to 50q raised to the power of minus 3 plus 0.8. Now, after taking the second derivative, we substitute this value of q into this second derivative and find the value of the second derivative of AC. If this value is greater than 0, then we can say that this function AC is at its minimum point. So don't forget that AC can also be written as 50 all over q raised to the power of 3 plus 0.8. So now, after getting to this point, the value of q is 3.1449. So I can say that the second derivative of AC is equals to 50 all over 3.1499 plus 0.8. Now divide this by this, that is AC, the second derivative of AC equals to 1.5999 plus 0.8. So the value of second derivative of AC is 2.3999. So therefore, the minimum point of this average cost function is 2.3999. You can proceed to approximate to 2 decimal places. That is, the second derivative is 2.399. You can proceed to approximate if you want. So that is how to find minimum point of any function. You first take the first derivative of the function. After getting the first derivative of the function, you solve for the value of the independent variable, which is q. After getting the value of q, then you take the second derivative of that same function, which is what I did here. After taking the second derivative of that same function, you are going to substitute the value of the independent variable, that is q, that you got here. You are going to substitute it and get the value of that function at the second derivative of that function. Then you go back to your knowledge about stationary points. So if the value is greater than 0, that means that the function is at its minimum point.
On this channel, you will find information, concepts explanation, tutorials video with detailed explanation that will assist you in gaining more knowledge and insight. In addition, our channel features past question, solution to questions you are likely to encounter in exam, solution to all past questions. Please kindly subscribe. All questions are solved with simplicity.